Hello, this is Larry Tingen. We're going to start working through our Math 143 lessons. And we're going to start out with Lesson 1-1, the review of percents. So at the top of the screen, you can see where we have our learning objectives listed out. We're going to be able to convert between percents, decimals to conversions, dealing with percent increase, decrease, solving some problems using the percent, and then evaluate legitimacy claims based on percent. So let's dive right in and let's talk about how do you convert a percent to a fraction. So to do that, you just drop the percent sign and then rewrite it as a fraction with a 100 in the denominator. So for instance, 73%. And I'm told to drop the percent sign and then rewrite with a fraction with 100 in the denominator. Another example, 36.3% over 100. All right. When you see the percent symbol, this is telling me that the number in front is divided by 100. It's a nice way to be able to write division by 100 in a paragraph or in a line. So that's a good reason for it. In my own research, I've found that this symbol being the percent, that it used to look like this. Well, let me try that again. It used to be a slash and then it was a 0, 0. Because a lot of times I've always wondered, why do I have a little circle top and bottom? Well, it used to look like this, where I had a slash and a 0, 0. Well, you can see where that would look like a 100. So I'm still interested in finding that out. So if you know anything about this, or if you've heard of this before, or something along that, send me an email, shoot me a text, or just send me an email, make a comment, because anytime I can bring in the history of math and try to make something make sense in today's terms, I always like to. How about percent to decimal? Okay, well, percent to decimal, let's stick with the same numbers that we've been dealing with, 73%. And it says drop the sign. Okay, I did that before. And then move the decimal point 2 places to the left. Where is the decimal in this number? Well, the decimal is like a speed limit sign. In the country, if the speed is 55 miles an hour, the road doesn't have to note that it's 55 miles per hour because lack of a sign means speed limit is 55. Same thing works for decimals. If you don't see a decimal in a number, the decimal is always to the right of the last digit. So for us, it is to the right of the 3 in 73. And then I'm supposed to move it 2 places to the left. So that goes 1, 2. This is its new home. And there's the decimal, 73 hundredths. Let's do it with our decimal percent, 36.3. I want that to be 60 so bad. 36.3%. Same game. Now, they showed me where the decimal is because it's not to the right of the last digit. Same work. Decimal moves 2 places to the left, and I'm looking at 0.363 or 363 thousandths. So I can go to decimal, I can go to percent, or I can go from percent to fraction, I can go percent to decimal. So let's take a look at some examples. We've done this, or something similar to this already, 47.3%. We know that that's going to scoot 2 places and become 0.473. Now, a 0.24%. We didn't give a specific rule on how to do this, but we do know how to go percent to decimal. So to go percent to decimal, I was dropping the sign. I was moving 2 places to the left. Well, if I want to go from decimal back to percent, guess what I do? Well, I move the decimal 2 places to the right, which is the opposite of what I did before. And then I add the percent sign back. So that becomes 24%. So 24 hundredths, 0.24 is 24%. And then lastly, I have 80% to a fraction in the lowest terms. Lowest terms just means that the numerator and denominator don't share any factors in common. So right now, 80% is 80 over 100. Both of those are divisible by 10, so that can reduce to 8 over 10. 8 and 10 are both even, so that reduces to 4 over 5. And now 4 and 5 have no common factors, so I'm done. Now, we're working through some of the examples in the text, and this was one that Dan Sebecki had written in. He went to a fundraiser for ALS Society. 30% of every purchase was donated to ALS research. His check was $25.49. How much was donated to the ALS Society? The question, while a valid question, we always like to try to take a math problem, take an application problem, and turn it into a strictly math problem. I'm looking for how much money of that check went to the ALS Society. I know the check is $25.49, and 30% of it went to ALS. So let's break this down. All I'm really asking is, what is 30% of 2549? Anytime we can kind of narrow a question down, remove any of the excess from it, and just make it a math problem, it tends to go easier. A lot of people struggle with application problems because the first step is the hardest, moving this from application from a word problem over to a math problem. So what is 30% of $25.49? So there's a couple of ways we can tackle this, and one of them, the easiest, is if I want to find a percentage of a number, all I do is multiply 2549. But here's the trouble. You can't do math with a percent sign. So I have to convert the percent to a decimal. So that becomes 0.3 or 0.30. And then I just multiply them. So what do we get when we multiply those? We get 0.3 times 2549, and I find it to be 7647. Now, this is money. The problem doesn't say how many places to round to, but it's money, so we'd round to 2 places. So that becomes $7.65, because that 4, we look to the right of the cents place or the hundredths place. The number to the right is 5 or above, so that means this 4 becomes a 5. Now, that's a direct way to find it. If you have a problem, it's just saying what is a certain percentage of a number. If you want to break this down algebraically, we have some key words going on here. What means the variable, okay, or the thing we're solving for. Is means equals. 30% of means multiply. So I can kind of convert this little broken down math problem into x, because that's what I don't know, is equals 30% of 2549. And that's exactly what we just did right there, isn't it? 30% times 2549. All right, small jump cut there. We just finished up that problem about the percentage for the dinner bill, so let's move on to calculating the original price of a sale item. This is a common problem that causes issues, so let's talk through it and see what happens. A leather store at an outlet mall is offering 70% off a jacket that is sale price at $59. What was the original price of the jacket? This one's not like problems we've seen up to this point, because instead of telling us the original price and then asking for the discounted price, they're telling us the discounted price and they want us to find what was the original price. So if the original price is 70% off and the result of that is $59, I can think of this problem two ways. So if the jacket is 70% off, that means the original price the original price is retained 30%. That's kind of a weird way to say it, but I want you to think of it this way. If you take the original price and you knock off 70%, you hold on to 30% of the original price. So that means the discount price, or the sale price, let's use the same words, is 30% of the original price. And now I can deal with that, right? So I'm going to let the original price be P. Okay, we get to make up our variables as we go, and P makes sense because it's the first letter in price. So what's 30% of P? Well, it's $59. They told me that in the problem. So that means 30% of P, of means times, equals $59. We can't do math with percents. We have to convert them to decimal. So that becomes 0.30 P is equal to $59. I want to get the variable by itself, so I divide both sides by 0.3. You don't have to add the 0 on the end if you don't want to, because it doesn't change anything. So that's 59 divided by 0.3, and I find out that P is 196, about 66666 forever. And this is money. So even though they didn't tell us how many places to round to, because it's money, we round to 2 places. That 6 going on forever means I'm going to round this to 196.6, and then I would do 6s forever. Well, that second 6 is the cents place, and beside that will be another 6, which means I would round that to a 7. So the original price is $196.67. Always be aware of these problems. Make sure you know what you're being asked to do. Like I said, typically you're being asked to, or all the problems up to this point you have been asked to, here's the original price, find the sale price. Now you got the sale price, find the original. Make sure when you do this problem that you get an answer that makes sense, right? If the sale price is $59 and you somehow end up with something less than $59 for the original, you know you did something wrong. So next, we got some Did You Get It's. These are from the textbook as well, so if you're following along in there, it's a great resource. So we're going to calculate the percents for each. Find 38% of 400, right? Just translate words into math. 38% of 400. Can't do math with a percent, so I've got to change it to a decimal. And 0.38 times 400, 0.38 times 400, 152. 152. Next, 17.49% is 20% of what amount? Here comes our conversions. Is means equals, of means times, what amount is our variable, right? So just plug in the rest of the numbers from the problem. 17.49 is 20%. If I want to do math with the 20%, I have to convert it to a decimal. And I have a problem very similar to the one we just did 2 times ago. 1749 is 20% of some number. What is that number? Divide both sides by 0.2. And we find x is what? 17. 49 divided 0.2, 87.45. If you're wondering, or if you're starting to pick up on this pattern, you can see that if you divide by a number that's between 0 and 1, the result of that division is larger, right? It happened here and it happened above as well when I divided both sides by 3/10 or 0.3. When you divide by a number that's greater than 1, the result of the division is always smaller than the numerator, the number you originally had. Okay? Problem had money in it, so that's why I have the dollar sign and around 2 places, but this naturally just cut off at 87.45. Lastly, what percentage of 42 is 15? There's the variable of times is equals, just plug in the numbers, 42, 15, x times 42 is equal to 15. I'm going to let x, get x on a side by itself. X currently multiplied by 42. I would like that to not be the case anymore, so I divide it by 42. If I do it to one side, I have to do it to the other, which means x is 15 over 42, which is what? 15 divide 42. It's a big old jumble of numbers, 0.357, blah, blah, blah. And it's just going to continue going on forever. Now, am I done? No. And I'm not done because the problem said what percentage. So I do have to convert this to a percentage. So to convert from decimal to percent, I move 2 places to the right, and I add the percent sign. So that means I'm going to go from here to here, which means I'm looking at 35.7, and I'm going to go to 2 places, not because it's money, but because that's just kind of what we've been doing. 35.71%. Why does this stay a 1? Because when I look to the right, the next number is a 4. If the number next to the number you're rounding to is 5 or more, you go up. If it's not, you leave it alone. And yes, this should be squiggly. Sorry. Because that indicates to the reader that you have rounded. And that just looks like a big old mess right now. So let's fix that and make sure it looks like it's intentional. All right. So what else can we do with these problems? When am I going to use this, right? Well, here's when you're going to use it. Okay. Maybe you're going to invest some money in the future. A real estate developer is looking for investors to fund a new condo complex. He promises 145% return on investment in 4 years. If you're interested in investing $30,000 and the developer follows through on his promise, how much money will you get back in 4 years? Now, this one, this is a dream scenario. You got $30,000 laying around, you want to invest it. So there's a whole bunch of words here. There's a lot of information in this problem. We're going to convert this to just the math part. 145% return on $30,000. That means you're going to make 145% of what you put in as profit. All right? So that means what? That means I need to know what is 145% of $30,000. Now, I know the problem told me it was going to take 4 years for this to happen, but I don't care how long it takes because all of it was asked is if they follow through, how much money am I going to get? What? There's that variable x, is equals 145% of means times 30,000. Okay? I can't do math with a percent. I have to convert it to a decimal. So scoot over and stick to your guns. The rules here are intentional. 2 places to the left and drop the percent sign. That's 1.45. Okay, 1.45 times 30,000. What's that going to give me? Well, when I multiply by numbers that are greater than 1, I end up with something larger than what I started with. 30,000 times 1.45, 30,000 times 1.45 is 43,500. All right, so there's the math. Now let's write the answer. This will be a return of $43,500. So how much money will you have in total? You're going to have the 30,000 you originally invested plus the return on the money, which is the 43,500 that you got. So that means at the end of this 4-year cycle, you will now have $73,500 because you have the original 30,000 you invested plus the 43,000 that you gained or you earned on that return. In the real world, a return of 100% or more is kind of unheard of. Maybe this problem this problem is trying to get you used to numbers, percents that can be larger than 100%. But in the real world, if you saw a 10 or 15 or 20% return on your money, that would be a good investment in the real world. All right, so let's keep going. Maybe get to a problem that makes a little more real world sense. Not a ton of us have that 30,000 laying around to just invest. So how about we are looking through some advertisements, and Macy's has 2 different coupons. They have one that offers 15% off any purchase of $50 or more. The other offers 20% off any item. So if I found a dress shirt, yeah, you noticed, change the shirts between the lectures. If I find this shirt for $79, which coupon should I use in order to pay the lowest price possible? So I've got 2 cases here. I have the $15 off any purchase of $50 or more. $50 or more. And then I have the 20% off any item. So what do I have? Well, I know if I use the $15 off, that's super easy math. $79 minus the 15 off means I'm going to pay $64. All right. So is this better than getting 20% off? Well, let's find out. How do I take 20% off an item? Well, if I get 20% off, that means I just want to figure out, what's the discount? So what is 20% of 79 bucks? Okay. What? There's the variable is equals 20% of is times $79. Convert the percent to a decimal. After you do a few of these, you don't have to write the percent again. You'll just start to naturally convert that to its decimal form. 0.2 times 79. When I multiply by a number between 0 and 1, and what happens? I end up with something smaller, and that should be right. 20% of 79 should be less than 79. It's $15.80. So that means this was the discount if I use this coupon. So what would I pay for the shirt? I would pay $79 minus $15.80, which is, right, no reason to make mistakes because we don't want to use a calculator. $63.20. All right, now this is money, right? So we go to two places, we do add the dollar sign. That's the better deal, right? So since that's the better deal, we should use the 20% off any item. I need to say that in my answer, right? The question did not say find the result of buying this shirt with both coupons. It said figure out which coupon is better. So we do need to state that the 20% off any item is the better deal for us. Right? I know it's only saving 80 cents, but it's saving 80 cents. So that is the better deal. Now let's go to a problem that I dealt with last year when I was bought a new house, and the refrigerator I had at my old house did not fit in the space in the kitchen. So because of that, I had to look into a new refrigerator, and there were two deals. Okay, there was this is similar to my situation, but not exactly. The regular price at Home Depot for a refrigerator was $1,149. At Lowe's, it was $1,219. But Lowe's is offering 15% off. Home Depot is offering 15% off. Lowe's is offering $200 off the purchase on store credit, which is the better option. So we're going to assume 15% off from Home Depot just off the price. $200 in store credit. We're going to spend that because if we're buying a fridge, we probably need to get some other stuff for the house. So this one's slightly different than the problem before because I start with two different prices. So at Home Depot, the fridge is originally $1,149, and then they're offering 15% off. So, and then at Lowe's, the easier one to calculate is the price is $1,219, and then they're going to give me $200 in store credit. That one's easy to calculate, right? $1,019. So this is what I would pay for the fridge at Lowe's. What am I going to pay at Home Depot? Just like the last problem, I've got to do some math here. I've got to do the calculation. So find 15% of 1,149, and then I'm going to remove it from, or I'm going to subtract it from 1,149. So 1,149 times 0.15 is what? I always like bringing it up on the screen so you see exactly what I do. 0.15. 17235. 17235. So that's the discount. So how much am I going to pay? 1,149 minus 17235. 1149 minus 17235. 97665. So this is what I'm going to pay at Home Depot. Which one of these is better? That one is Home Depot. Better option for us. Right? Because it's less. We're going to end up paying less for the fridge. Okay. So let's keep going. And the last part of 1.1, we're going to be dealing with percent increases and decreases. They're going to work the exact same way. If you want to figure out, so let's say your salary goes up 3% over the year. I want to calculate how much that is, or I want to actually calculate the percentage. Let's say I got a $200 raise on my overall salary for next year. I want to know what percent increase that is, or the price of something has gone down 4% or has gone down $50. What percent decrease was that? And how do I find it? All I gotta do is figure out how much it went up or down. If it's an increase, it's the amount of increase goes in the numerator. If it's a decrease, the amount of decrease goes in the numerator. The denominator is always the original amount, not the new price, the old price. All right? And then the calculation for the percent, how do I get the amount of increase? I just take my new minus my old. How do I get my decrease? Same thing, new minus old. Okay? So let's get to a problem. In 2019, state minimum wage in Missouri was raised from $7.85 to $8.60. In Massachusetts, it went from $11 to $12. Which state had the higher percent increase? All right, so let's get in here and deal with Missouri first. So Missouri has raised their minimum wage from $7.85 to $8.60. So this is a percent increase, right? So percent increase, I need to find what's the new amount, what's the original amount, and go from there. Well, just based on the problem, if it's increased from $7.85 to $8.60, this is the new, and this is the old, right? Or original. Same thing, it's just old has a lot fewer letters. So percent increase is the new minus the old, all divided by the old. The new is $8.60. The old is $7.85. The denominator is the old, which is also $7.85. On a calculator, no need to break this up into two pieces. Let's do it all at once. 860 minus 785. Enter is 75 cents. That's how much that's the amount of the increase, right? So I went up by 75 cents. So that's my numerator. And I just divide that by 785. And I find that to be 0.09554, so on and so on. 0.09554. Now, am I done? No, because they ask for a percent increase, so I do need to convert that to a percent. And what do I get? Take it to a percent, scoot over two places, and I'm looking at 9.55%. And we do want to indicate this is an increase. Okay. So what about Massachusetts? Massachusetts went from 11 to 12. So same thing. This is the new. 12 is the new, 11 is the old. So what is its percent increase? I'm going to shorten that to PI. I decided to make that a uppercase N there at the last second, didn't I? New minus old divided by old. The new is 12, the old is 11. I could do that math without a calculator. 12 minus 11 is 1. So what's 1 divided by 11? 0.9090. Notice that pattern. 9090. That continues on forever. And since it just continues, I can shorten that by just putting the bar over it to indicate that pattern continues. And it's just the 90 that keeps repeating. If I'm going to convert this to a percent, I need to go two places over and round. That should be rounded as well. And so what do I do here? The decimal goes here. I'm looking at 9.09% increase. Right. So we have our 2% increases, but once again, just the numbers aren't the answer because the question was what state had the higher percent increase, and the answer is that Missouri. The higher percent increase. Because we always like to be able to compare two things, and so if you were, let's say, if you were the state of Missouri and you wanted to attract people to your state, you would say, hey, we increased our minimum wage by 9.55%, while Massachusetts only did it by 9%. And then if you're in Massachusetts, you wouldn't talk about the percent increase. You would talk about our minimum wage is $12 now. So whereas Missouri's is $8.60. So you can see how even using numbers, you can end up with two statements that are both true, even though one makes one state look good, the other makes the other one look good. So last problem on this page is about CEO pay. So in order to show solidarity, a CEO is taking a $300,000 a year pay cut. That sounds amazing, especially if maybe the CEO was directing this money to go to employees that were underpaid. Last year, the CEO's pay was $11 million. We want to find the percent decrease. So percent decrease, it works the same way. Is what? Well, it's the new minus the old divided by the old. I don't have those two numbers given to me in the problem, but I can find them pretty easily. The person was making $11 million, so that's the old. They're taking a $300,000 cut, so that means 11 million minus 300,000. I mean, I don't know how they're going to survive on $10,700,000, but I guess they'll find a way, right? So this is the new. So the new is 10,700,000 minus 11 million divided by, and we go for the old in the denominator. And what do I find? I find that million has a whole lot of zeros in it, right? So 10,700,000 minus 11 million. We know that's going to be 300,000 because that was the pay cut. So that was the amount of decrease. And then we divide it by the old salary, which is 11 million. 1, 2, 3, 4, 5, 6. And I calculate negative 0.02727. We're seeing that repeat again. 0.027272727. That continues on forever. The question is asking for percent decrease, so that means I do need to convert this into a percent. So let's write out just because we know it's just going to keep repeating 272727 and convert it. So if I scoot over 2 places, this is where my decimal place goes now. So I'm looking at negative 2.7, and then I'm going to round to 2 places. So that means I'm looking at this 2. Does it stay a 2 or become a 3? This becomes a 3 because the number to the right is 5 or more. Okay. And there's my answer. I have a percent decrease of 2.73%, which I would write that out in a statement instead of saying a negative 2.73% decrease. And say the percent decrease is 2.73%. I don't want to say the percent decrease is negative 2.73 because that's kind of like saying that's like the ain't never. that's the double negative of math, well, the double negative from English at least, we will just state it as a percent decrease. All right. And then the last page for the 1.1 notes, we're just going to do the first three parts of a application problem, and we're going to do it piece by piece, see how we're doing with our percentages. So suppose you're shopping on a rack that's 40% off the lowest ticketed price, and you are interested in a sweater with a ticket price of $47.99. So if the sweater is 40% off and it has a ticket price of $47.99, I want to know what's the discounted price going to be. So we know, as we said in one of the first problems in this section, we know that if 40% is being subtracted, that means 60% of the ticket price is what's going to remain. So I want you to think of it this way. If I know that my price, so let's see here. So what is my sale price? My sale price is going to be whatever the original price was, which is 100%, minus 40% off, right? 100% of the price, the original price, minus 40% of the original price is going to give me, what? 60% of the original price, right? So I can calculate this two different ways. I can either take the sale price and then find 40% of that sale price, and I'll end up with 60%. So what do I mean? Times P times P times P. And then you know we can't do math with percents, so this would become, what, 1.00 original price times 0.4. The original price is equal to 0.6 times the original price. P is the original price. So I can either calculate this, I can either find the 40% discount and subtract it from the price, from the original price to get the sale price, or I can just start at the end here and say, well, if it's 40% off, then that means the sale price is going to be 60% of the original price. So I've done it both ways. So we'll follow along that math. Ticket prices, I can round this up to 50 easily. So let's estimate the price by doing so. So it was a $47.99 item. The sweater was $47.99, so we're going to call it 50. We're trying to do some general math, make sure when we get to the cash register we have an idea of what we've done. So we're going to round $47.99 to 50. And I'm going to estimate the sale price by taking $50, and I'm going to multiply it by 0.6 because I've removed the 40% off, means I've got 60% left. 5 times 6 is 30, and then I got one decimal place to keep. So where does that put me? 5 times 0.6 is, well, 50 times 6 is 300, and then the decimals here. My factor has one decimal place in it, so that means I need to move over to the right one place. So I'm looking at an estimated price of $30. Now, let's find the exact discount. The exact discount price. So, or I'm going to call it sale price. It's the same thing. 0.6 times $47.99. Why would I want to do the estimate? Because even though we were always told we'd never have a calculator everywhere we go, and then it turns out we do in our phones, in our pockets. Just because you have a calculator doesn't mean you actually want to sit down and calculate this exactly. 28794. 28794. This is money, so I'm going to round to the nearest cent, look to the right, that 9 stays a 9. So I'm going to have a discount of $28, or excuse me, discount price of $28.79. That's my sale price. And this is my estimated sale price. Is it a good estimate? Yeah, that's a decent estimate. And if you're doing estimates, it's always nice to overestimate what you're going to pay, so that way you don't get surprised when you get to the end, right? If I had rounded that $47.99 to $45, I would have had a different estimated price. That estimated price would have been an underestimate, which is worse for us. We don't like to see that in our budgets. I'd rather have a number, if I get to the register and I know, okay, this is going to be under $100. That's much better than me saying, it's going to be more than 80. I just don't know how much more. So that is section 1.1.